I want to welcome everyone back to day 2 of the Northeast RISC Symposium. My name is Dan Bonajudo. I'm one of the organizers of this event, and I'm very excited for the day we have ahead. You can see the schedule here. We're going to open in a moment with a session about communication around climate change and invasive species. And then after a brief lunch break, for those who are interested, we'll have opportunities to get into smaller groups and breakout rooms to discuss specific topics related to invasive species and climate change. Then after that, we'll start our afternoon session, which is a panel about invasive species impacts on climate change, adaptation and mitigation efforts. And we'll end with some lightning talks and closing remarks. So that's the plan for the day. Before we get going, just a few housekeeping things. We are using a Zoom meeting format. So that means at any point you could unmute yourself and speak. So please stay muted so we don't distract from our speakers. Just be aware of that. We also are recording this. So just know that if your camera is on, make sure that it is the image that you want to present to the world, because you may be recorded if your camera's on. And finally, we have enabled closed captioning. If you want to use that, you can click the 3 dots on your Zoom panel and follow the instructions for turning captioning on. And the last thing I'll say, which is just in terms of communication, we have an active chat and we encourage people to use it. And if you have questions for the speakers, there is a Q&A box that you can add your questions to, and the moderators will ask those questions. And if there are questions that other folks have asked that seem particularly interesting or important to you, you can upvote those in the question and answer box by clicking on it. That is kind of the main logistics. The other thing I will say is Zoom has these nifty little emojis where you can clap or smile and react to things that speakers are doing. And that is often a nice way in these meetings for us speakers to know you're out there. So feel free to use those freely. And with that, I am going to end my screen share and turn it over to Emily to get our first session going.
Hey, good morning, everyone. Thank you so much, Dan, for kicking us off. My name is Emily Postorero. I am on the Northeast RISC leadership team. I'm a program development coordinator at the Invasive Species Center, which is a not-for-profit based out of Sault Ste. Marie, Ontario. I am really excited to be moderating our session this morning. I think this is going to be a really unique session within the symposium as a whole. Probably some of us here are scientists or are practitioners or leaders or volunteers in some way. And obviously all of us know the importance of communication. We all do our work and we aim to convey that work to the public, usually with some sense of urgency, accuracy, of course, and often creativity and sometimes sensitivity as well. And so in this session, we're diving right into that. We are going to be exploring different perspectives on invasive species, different messaging strategies, naming conventions, and language consideration with regard to our themes of the symposium. So without further ado, I will introduce our very first speaker of the day. Please welcome Juliana Barrett, coming to us from the University of Connecticut.
Great. Thank you so much. I'm going to jump right into sharing my screen here. So I'm really excited to be here today. And what I'm going to talk about is using a theme of regeneration in talking with people about ecosystem resilience, climate change, and invasive plants. My background's in plant ecology, so most of this is really focused on plants. So for that perspective. So I want to start off by talking about first, what is this idea of regeneration? And if you think about the Earth Day movement, it's sort of the Earth Day movement with climate change and much more of a focus on diversity, equity, and recognition of indigenous people's knowledge, incorporating all that into this idea of conserving, protecting our ecosystems and restoring them. During COVID, there was a huge emphasis on getting people outside, and this also builds on that. Oops. There we go. So in this graphic, I think we can think of biodiversity as a communications concept connecting climate change with invasive species. Biodiversity has positive connotations for the most part. People understand what it is. So it's a great tool to think about in this framework. Just real quickly, in terms of climate change projections here in Connecticut, where I'm based, but really I think it's pretty much the same throughout New England. We have warmer air temperatures, more hot days, more heat waves, more intense tropical cyclone events, whether it's hurricanes or tropical storms. We've all been experiencing these more intense precipitation events. And the one piece of good news, we have a longer growing season, but on the other hand, frost events are unpredictable now. So we can't say, oh, don't plant until the last full moon in May. And all those adages that we have around when to plant just don't work anymore. So in terms of climate change with these warmer air temperatures, they certainly impact the winter survival of many of the invasive plant species and pest species. We see an earlier emergence of certain invasives. Certainly, I look out my window every day now, and the only things that are even thinking about greening up yet are the invasive plant species. And then we also have the potential for new weed, invasive insect and disease species. So the thing about climate change and invasive species, one of the many issues in communicating about climate change is the sense of it being an overwhelming issue. And as an individual, really, what can I do? And people are always looking for that. And I think invasive species present that opportunity because they're connected to climate change. And for at least some plant species are actually something that people can get involved in terms of management and control. They can improve their surroundings, improve the biodiversity, and it's also an opportunity to connect with other people, whether multiculturally, multi-generationally. So I want to put this all into context with an example. And this is a project that I worked on with a local land trust, Avalonia Land Conservancy, in southeastern Connecticut at a Hoffman Evergreen Preserve. This preserve is about 200 acres. And it's a much used 200-acre preserve, lots of trails in it, but it was a really, really stressed system over time between hemlock woolly adelgid, the spongy moth, invasive species, plant species. There were droughts, there were major storm events, including Irene and Sandy in 2011 and 2012, had all really taken a toll on this preserve. So it was dangerous. It was not a healthy forest ecosystem. And so what the land trust decided to do is a series of 5 patch cuts, and you can see those numbered here. The dotted lines are the skid trails that were used, and there were also areas that were thinned. So there were about 65 acres impacted. And the question was, what do we do with this? And how can we plan for a resilient forest moving forward, taking into account climate change and its impacts, as well as existing and potential invasive species? So we moved forward with a plan for this preserve, and we wanted trees of various ages. We wanted different forest layers, a diversity of species. We wanted to think about wildlife value, safety down the road. Minimal invasive plant cover is obviously one of the optimum outcomes. We wanted species that would have the ability to grow and reproduce successfully, a key part of that in a future climate. We were looking out at 2050, and we wanted to add to the diversity and resilience with additional species or genotypes. So we ended up we came up with a plant list, put in 1,000 saplings, many of which were current species that are already there. We had seed mixes that were scattered on the skid trails, and this was often done by really young folks, Cub Scout groups, for example. And then after planting, We had volunteers who came back and worked on all the nuisance species such as birch and beech that were just popping up everywhere, as well as invasive species that were threatening the growth of our saplings. And so what we used in terms of a context for this project in bringing in new species was this idea of assisted migration or range expansion. These definitions, the three definitions, the three different types that you see here are from the US Fish and Wildlife Service. We focused on assisted range expansion, which is moving species, whether seed or populations in from their current range to suitable areas just beyond their historic ranges, mimicking natural dispersal. So these maps are a really great communication tool to talk to people about why we could bring in sweet gum or liquid ambar, and why it's part of this assisted range expansion as opposed to bringing in something that's new and invasive. So the area that we're working in is right on the Rhode Island border here in southeastern Connecticut. And here's the existing range of sweet gum. You can see it's already in southwestern Connecticut, in Long Island. You know, extending its range into southeastern Connecticut is not a big leap. Similarly, here's eastern redbud, already in Connecticut, on Cape Cod. So again, not a big leap. And I'm just showing you one more map because these maps, people really love to see these maps. Virginia pine, it's already on Long Island here and already in the southwestern border of Connecticut. So these maps were a great communication tool. And in terms of engagement and communications, we had many blog and newspaper articles. We had a 4-part webinar series. There was a hands-on workshop in the field, and we did many intergenerational field trips. But the work parties, even though they're the most labor-intensive ones to put together, are the best opportunities to communicate with people about climate change, about invasives, about what they're planting. It's hands-on. People share their experiences about what they're doing. So this was a really wonderful opportunity to have that engagement. And as part of this project, we also collected GPS locations for all the species, for every single planting that we did, with the hopes that, you know, 50 years from now, some of those Cub Scouts are going to come back. They can GPS what's there and see if any of these species survived. So just to wrap up, here's a couple of key points. People are much more aware of invasive plants than they were a decade ago. You don't see people making bittersweet wreaths anymore, for example. In all the oral and written communications, I always use Latin names as well as a common name, because people have so many common names for the same species, and it gets really confusing to make sure we're all talking about the same thing. So those Latin names are really important. Conducting invasive plant management in context, I think, is critical. And this ties into the last point, but you know, you could have a group going out, you know, a 10-acre preserve or a 100-acre preserve, and saying, you know, they walk in and they're hit by all these invasives and they immediately want to say, oh, we need to work right here. And I think it's really important that an entire area be looked at, because you may find that that area where you started has so many invasives that it's just not going to be a doable place to manage. And instead, there could be another area where there's only a few invasives, and it's much more manageable, and you have a much higher chance of success in terms of controlling those invasives. People are really interested in a list of potential invasives. So what could be coming into our area because of warmer air temperatures for the most part and changing climatic patterns. Encouraging this multi-generational and cultural interactions, I think, is something that's really important that we should all be putting a lot of energy into. And it's not enough just to manage the invasive species, but to do our replanting with climate change in mind. And there's a lot of data or scientific data that's been collected that shows we can't just manage and leave an area because it's just going to populate with invasives. And so that's the end of my presentation, and I'm happy to answer any questions. Stop sharing.
Wonderful. Thank you so much, Juliana. And yeah, we do have a fair bit of time for questions. So if anyone has, we have a few in the chat already, or in the Q&A, I should say, but if anyone has more, please pop those in. Okay, let's start with the first one here. So are there any adverse impacts to the native plant community at Hoffman caused by excessive deer herbivory?
Absolutely. We actually put deer guards up on, mainly on the evergreens that we planted, which made a huge difference. Just, we could see where deer were really trying to get at them, sometimes successfully when we didn't put deer guards on everything. It's definitely an issue. Yeah, and you kind of hope to have enough plantings that survive, but hard no matter what you do.
Of course. And how many people were in your work parties?
It was always a range. The land trust was really the one land trust person would put out a call, and she had a group of people who would come out every time she asked. So it could be up to 25 people, which is a lot to manage, but made for quick work. But it was amazing that we had 80-year-olds out with 20-year-olds.
Yeah, that's great to hear. Okay, all right, there's this one. So regarding the documented native ranges of various plant species, do those documented ranges account for anthropogenic range expansion brought about by indigenous people in the centuries before the first European settlers arrived?
That is an excellent question, and I don't know the answer to that. Yeah, I don't know, but it'd be fascinating to try to find out. I think most of those documented plant occurrences are based on herbarium records. So probably it does not take that into account.
Okay. This is a good one. Can you clarify the difference between assisted migration and assisted range migration?
So what we were doing was that assisted range expansion. So that would be species that are on the edge of the current range that are likely to move into those areas. So sweet gum is a nice example because it's planted all over in people's yards, in towns and cities. So it's already in the area that we were planting. But native populations were not already there. And we knew, that's something that will likely spread naturally. So by using those maps, we were able to see what is the existing native range of these things. Redbud's another good one. People have that in their yards all over the place. But again, planting it so that it becomes naturalized in these areas was part of our plan.
Got it. Okay. All right, we've got several votes on this question, so I'm going to put this forth to you. In choosing plants for assisted migration, what criteria are you considering? Are these species that are aesthetically pleasing, or are they serving specific ecosystem functions?
So another really great question. So we did document the physical characteristics of our site. So we knew exposure, moisture regimes, the soil types. So we looked at the physical aspects. Then we looked at the expectations in terms of climate change, in terms of air temperature, precipitation patterns. And based on that, came up with a list of potential species that we thought would work. We narrowed that down by wildlife value. And then we narrowed it down by what was accessible to purchase. You know, a lot of the things that we wanted to plant, we couldn't find any good sources for them. All our lists were vetted through state agencies. We had state foresters look at them. So it went through an extensive process to try to come up with that final list.
Okay, thank you. Okay, a few more questions here, and we still have some time. Where did your list of potential species to plant come from?
We developed that.
You developed. Okay.
So we looked at what was already
Yeah.
there, and then we looked at a lot of those maps that I showed you to think about what could come into this area.
Okay, and that actually segues well into the next question. Are your species maps available online?
Species. No, but these were all maps from the USDA. So, you know, we would look up the different species and find the range maps.
And then, do you have any pushback on expanding the range of plants that are non-native at the moment? Any other techniques to increase understanding and reduce pushback?
So let's see. So the state was pretty adamant that we not plant anything that was listed as endangered, threatened, or special concern. So for example, there was a more southern viburnum species that we were originally thinking about, and they asked us not to plant that. And then in the webinars that we did, one of them was very specifically about what we were planning to do on the site. And that there was a lot of questions, people saying, well, why isn't that invasive? You know, what makes it okay to do this? And we weren't just bringing in some new species, we were also bringing in like more southern. So we got a lot of plants from the Maryland State Nursery, for example. But we were getting red oaks and white oaks, things that are already here, but we wanted to expand the gene pool basically. And so, yeah, there were a lot of questions, and it was good opportunity to talk to people about that.
Okay. I think we have time for just one more question, if you can answer in a couple minutes. Were there any difficulties in the continuing control of invasives at Hoffman by the presence of the planted native species? I guess so, like I think that means once you had natives planted, was it more difficult to, yeah, control the invasives that were still there?
Yes, because, you know, we want to work around them.
Yeah, of course.
And so, yeah, it's not like you could just go in wholesale and do a whole bunch of cutting or herbicide or any of those things. We had to be really, really careful about what we were doing.
Okay. All right. Well, I think we are just coming up short on time, so I'll stop there. Thank you so much again, Juliana. And if any other questions pop up in the Q&A or you want to respond to anything in the chat just by typing, feel free to do so.
Great. Thanks very much.
Okay, so we are moving on to our next speaker. We'll hear from Susanna Lidstrom, who's coming to us from the KTH Royal Institute of Technology and the University of California, San Diego. Welcome.
Thank you so much, Emily. I will share my screen. Do you see my screen? Okay.
Yep, it's full screen now. Looks great.
Great, thank you. So thank you so much for inviting me, and thank you, Juliana, for a very interesting talk. So I come at this from a fairly different perspective. I'm a historian of the environment, studying environmental narratives. So my perspective is a little bit different. So I will talk about invasive species as what we call an invasive narrative, and I will explain what I mean by that. So first, I want to acknowledge that most of my talk today builds on an article that I wrote a few years ago with Simon West, Tanya Katchner, Isabel Perez, and Hedley Tweidel. So I just want to acknowledge my co-authors here. Sorry. So our study started from observations of what was called the Alien Busters campaign, an initiative in South Africa to encourage scientists, but primarily citizen scientists, to combat invasive species in South Africa. So in this campaign, alien species were described as a threat to native biodiversity, cultural heritage, national water supplies, and economic prosperity. Campaign materials stated that it is time to reclaim our country. We need the public to join us in our fight to rid the planet of these deadly invaders. We need as many people as possible out there to become alien busters. So in short, this campaign declared war on alien species. So the name of the campaign speaks to the movie Ghostbusters that some of you may know, where a group of scientists embark on a mission to eradicate supernatural intruders, encouraging scientists as well as citizens to similarly save society from this advancing threat. A more recent example, also from South Africa, is an article in The Conversation from a few years ago, starting by stating that there is a massive army marching across South Africa. It's silent and looks harmless, but it's growing by the day. It's depleting the country's water supply, intensifying wildfires, reducing agricultural productivity, and threatening globally significant biodiversity. This is South Africa's unwanted army of over 380 invasive alien plant species. Another recent example is from a Swedish campaign created by the NGO, the Field Biologists. It's an annual campaign where they meet once a year for what they call the Great Lupine Combat Day, with the slogan "Save Biodiversity, Fight Lupines." So this is so people gather on a particular day to clear lupines in a particular location. So these are just examples of the narrative surrounding invasive species that we have studied. So we study these descriptions as environmental narratives, which means that we consider how they frame and describe the issue at hand, how they portray the broader relationship between nature and society, how they include social as well as ecological dimensions, and what kind of implications they may have. Our study draws especially on a study by Rob Nixon called Slow Violence and the Environmentalism of the Poor, published in 2011. It's a foundational study in our field. So in this book, Nixon shows that some of the most profound contemporary environmental crises are underrepresented in media and politics because they are not easily represented through what he describes as sensation-driven news reports or the types of individualized narratives we traditionally use to make sense of our surroundings. So specifically, he shows how environmental impacts that are slow and incremental, delayed and displaced through time and space, and where cause and effect are not clearly visible or related, are underrepresented in media and public perceptions. So we built on this analysis to argue that there is also a different kind of environmental narrative that are easier to formulate, and that once formulated easily gains traction across specifically these domains of media and public perceptions. And we suggest then that invasive alien species is one such narrative. So several specific features of the invasive alien species concept make it successful, or as we say, invasive. So it draws on clearly recognizable temporal and spatial dimensions, the invasive and the alien, referring to time and space, that make, as Charles Warren has stated, intuitive sense in our heads. So this imagery is easily translated into public agency as well as political clout. The narrative structure of this concept reflects pre-existing narrative formats that we are very familiar with in our Western traditions, the good versus evil, the idea of invasions, etc. It's a performative narrative that translates into individual actions, and it travels well across the realms of science, policy, law, and media. So finally, whereas in some ways it is very good and appreciated to have a narrative that communicates science so well, or so effectively, at least. There are also some tensions in relation to concerns about how this narrative represents ecological and environmental processes. So some concerns that we point out and that others have also discussed at length include that the invasive species concepts may reduce complex processes to simple dichotomies. For example, that it's easy to identify what is native versus what is invasive. On the contrary, when you consider these definitions in depth, you have to be quite specific about what historical baseline you are using and what other kind of choices or assumptions you are making in this distinction. Furthermore, it creates a nature-cultural divide that in some ways reflect outdated views of the relationship between people and nature, suggesting that what is worth striving for is some kind of pristine nature that existed in the past, rather than negotiating, especially in light of climate change, what may be potential environments of the future. The narrative in all its different components draws also on human histories of migration and colonization and associated xenophobic terminologies. It also fosters an attitude in some of its extreme formats, at least that I was quoting in the beginning, an attitude towards the natural world focused on ideas about combat, control, and eradication, where you might see alternative ideas centered on different kinds of ideas, centered on care, adaptation, and negotiation. So thank you.
Okay, thank you so much, Susanna. That was a really interesting talk. We have plenty of time for questions. So if you have anything, please pop it in the Q&A. I'm not quite seeing anything yet, so maybe I will do my best to kind of get the conversation going here. I'm curious as to your thought, because I mean, I work at the Invasive Species Center, so you know, my whole kind of job is premised on categorizing some species as invasive and others as not. But I mean, I am a student of ecology, and for a while, you know, I've kind of thought of invasive species as less so like a strict ecological concept and more one that's just kind of translates easier into our management goals. Because, you know, we also manage native species. I mean, we had, I just kind of skimmed it, but in the chat here, people are talking about deer and deer browse, right? White-tailed deer are native species around here, but we do manage them to some extent because we kind of recognize that we have certain ecological goals, right? We have management goals, and so sometimes it is kind of easier to dichotomize it a little bit. I guess I'm kind of wondering, does your research kind of focus a little more at the level of discourse, or do you go deep into, like, you really think we ought to challenge the idea that there are invasive and native species and you kind of can't really strictly categorize it like that? Am I sort of getting at the question properly?
Yeah, no, I think it's a good question because, well, part of it is also in my field where we're both focusing more on identifying problems than presenting solutions, I'm afraid. But I think, you know, the field, as you say, the discourse is very entrenched in the field, and I think, you know, that is, it also, you know, it also reflects, you know, a very real problem, I would say. So, but I think you can still pay attention to how far you are stretching this discourse. I mean, you don't have to go from, you know, talking about invasive species to talking about, you know, war and eradication and combat. I mean, that's still quite a leap, and I think you don't have to perhaps go that way you can be aware of your, where you take that discourse. And then I think you can also, another thing I think is important, as also came up in the discussion after Juliana's paper, that you can talk about, what are the histories that we are considering, and why are we choosing certain species, and why, why are we making the choices we make, and not, and I think all invasion biologists know this, but to make it explicit and not make it explicit that you're making these choices, and that it's not, a readily available category.
Right. Okay. Well, we've got some questions popping up here in the Q&A. I'm going to try and get to as many of them as possible. Okay, let's start off with the first one. Do you have suggestions of a counter narrative for our communication about invasive species? And I think you touched on it a little bit about saying, like, you don't have to go into war and fear mongering kind of metaphors.
Well, I think there are interesting other, and I think Juliana, again, like regeneration, I think is a, it's a different kind of term. The idea of rewilding also, I think, speaks to this to desire to manage ecosystems in a way that they have different kinds of values, but it doesn't rely on this historical sort of these historical assumptions. And so I think there are several different ones. They are not as entrenched yet, but
okay. I think this question maybe kind of flows into that a little bit. Do you have any tips for communicating that there is a relationship between plant migration histories and human migration and colonization without completely conflating the two?
Yeah, I think there are no general tips. I think it will be different in different locations. The South African case that we were studying was, of course, perhaps more than many other areas, really, intertwined with this colonial history and national identity and these issues. And I think it will be different for, depending on where you are. The question came up before about, the colonization of North America and how that impacts, and that will be different from Europe and so on.
Of course. Yeah, and how do we migrate to less charged language while creating a narrative that motivates action? I think this is maybe another one that maybe doesn't have a blanket response, but if you wanted to kind of take a stab at it.
Well, I think it's really interesting, this idea of how you go from these global challenges to, approaching the individual. I don't really have a good answer. It's very difficult. And I think, just as Juliana was saying, this invasive species, if you take climate change and then you bring it into these kind of ecosystem dynamics, you can then translate it into something that a community can gather around. And I think that's fantastic in many ways. So yeah, I think you can just pay attention to the language you use when you motivate these actions, and perhaps, encourage reflection and things like that.
Okay. Yeah, I like that, encouraging reflection. I think that's always kind of a good,
Rather
that's a
than
good
this,
blanket response. Yeah.
attitude.
Yeah. Okay. All right. This question here got a lot of upvotes, so I'll ask you this one. Any more comments on the concerns related to xenophobic language at a time when there's so much political language? Do you think there should be changes to the language we use to avoid terms similar to the language used related to border security?
I would say yes. I think that's really unfortunate to have those overlaps. Yeah, I think I think it's terrible if you use, you move into the environmental dynamics and drawing on these fears that some people have of migrating people.
Right. Okay, I think I will try to squeeze one more in before we get our last speaker on. Okay, is there generally a time scale you think of something as native, that since colonizers started recording the existence of a plant in the example of the United States?
Well, I think once you start thinking about it, I mean, the Earth has, continuously changed throughout both Earth history and human history, and those are really, it's really impossible to definitively categorize anything as invasive or native. And it's also, I think that those categories should not determine the value of different plants, and different plant species will also have different values to different groups of people. So that's another dimension that I perhaps didn't highlight as much as I should have, that these in our South African context, we had a case where there was one invasive species that was really common, and it was used in some areas for firewood. And then, these plants were cleared and others were, there instead. And so that took away this use for some groups of people. And so I think, we need to be careful about generalizing too much.
Right. Okay. Thank you so much for your responses and for an excellent presentation. There is still some, it looks like, activity in the chat and the Q&A. If you are able to stay and type some responses if you would like to, please feel free to do so. Thank you so much.
Thank you.
Okay, and last but not least, I would like to introduce our final speaker for this session, Nick Rio, coming to us from Simon Fraser University. Welcome.
Bujugi Kanawia, Tigetnim Wendan Nagishkunan. Hi everyone, happy to meet you all, and greetings from Coast Salish territories out here in Vancouver, BC. I just want to start out and say that my comments today are intended specifically as a thought provocation. So I'm offering a way of conceptualizing or making sense of some of the broader issues tied to introduced species. And that, more so than like a communication strategy in this case. So just keep that purpose in mind as you take in what I've got to share today. So I'm a Turtle Clan Anishinaabe. I'm an enrolled citizen of the Sault Ste. Marie tribe of Chippewa Indians, which is a group of Anishinaabeg or indigenous people from a place that we call Bawating, also known as the twin Sault Ste. Maries on either side of the St. Mary's River. There where Emily lives, our host or moderator. So the St. Mary's River is kind of the center of our home place. And it's the sole, as many of you know, it's the sole outflow of Gitchigame, or what we also call Lake Superior. So you got one of the biggest lakes on the planet, and it has just one outlet. And this creates an enormously powerful flowage that formerly, in the past, it cascaded down a long, wide set of rapids that gave Bawating its Anishinaabe name, which loosely means place of the rapids. So those, our rapids were destroyed and replaced with the Sioux Locks in the mid-1800s to allow for widespread extraction of ore, primarily, and timber, as well as other parts of Anishinaabe, which is our term for what the Anishinaabe use for our homelands. And I put some of the language that I'll use, the Anishinaabe language that I'll use, I put it in our chat for you. So the flowage at Bawating was historically and still is to an extent a haven for a diverse collective of plants and animals. For millennia, the abundance of wild foods in that area was a breadbasket for the Anishinaabe and neighboring indigenous groups. Now, Bawating sits at what we think of as the heart of the Great Lakes, which is one of a kind freshwater region of the earth. And from this heart center, Anishinaabe, we draw expansive connections and relationships across time and space. So, there's Anishinaabe communities based as far west as Alberta, clear across to Quebec in the east. We live almost as far up as the south shore of Hudson Bay and all the way down south into Oklahoma and Kansas. We even have a linguistically related cousin community down in Mexico. And that's not even counting all the diasporic Anishinaabe living around the world these days. And then we also make connections upward away from the earth, where Anishinaabe understand clearly our deep connections to the moon, the sun, and all the stars in our night sky. So the world of the Anishinaabeg is expansive, but it's also bounded by what we can call natural law or Anishinaabeg law. And I'll touch on just a few examples of some of the basic principles of Anishinaabeg law. And if you want to take a deeper dive, I'd suggest reading some materials by, say, K. Stark from the University of Montana, or John Burroughs, or Robin Clark. Robin Clark is based right there in Sault Ste. Marie. So some of the teachings of Anishinaabeg law include that we should always consider the land and water first, and take no actions that are not beneficial to the land and the water. That all beings in creation are sacred and worthy of our respect. And that the Anishinaabe are the younger, weaker siblings to the rest of creation, because we rely on all other plants and animals, all other beings for our own survival. And so that dependency on all other beings, it morally requires us to take up responsibilities to help care for the land. So we benefit so much, we have to figure out things that we can do to contribute. So these are just a few basic elements of Anishinaabe law, but we could also describe these as our moral compass, or our morality. We could describe it as our indigenous knowledge or knowledges, or even our ideology. These are all terms that would be appropriate for describing what I just kind of went through. And Anishinaabe law is all of these things. It's a pluralistic arena that doesn't really fit into a narrow definition or a particular discipline. So within Anishinaabe law, protection of the land and water is primary. And by taking care of the land and water, we nurture a world where human societies have everything that we need to flourish. On the other hand, conversely, when we break natural law, it not only hurts the land, but eventually comes back and hurts our societies, human societies. But the Anishinaabe are imperfect, and I'm always careful not to romanticize our communities, past or present. We've broken and continue to break Anishinaabe law throughout our history. And a great deal of our Anishinaabe Gikendasawin, or knowledge, comes from lessons learned, from straying from natural law, from times when we've been more self-serving and failed to put the needs of the land first. Contemporarily, many of our failings in this regard can be directly tied to our indigenous polities being forced into corporate governance structures, and our societies being forced into settler capitalist economic systems. But nevertheless, the Anishinaabe, we've held on to our understandings of natural law, and in many cases, we're regenerating these understandings to guide our decision making. So the colonizer groups that came to Turtle Island from across Europe brought with them a very different set of first principles, driving their thinking and decisions about land and so-called natural resources. In the process of colonizing Turtle Island, Europeans used new ideologies that enable destruction, consumption, and toxification of lands and waters. No actions, regardless of environmental outcomes, are off limits as long as it makes enough money for the right individuals or the right class of individuals, and so long as the impacts can be externalized outside of the communities where those individuals live. Land, water, and other so-called resources are fungible commodities that can be bought, sold, replaced. And if you use everything good up in one area, you just move elsewhere and dig back into Mother Nature's endless buffet. Land and water protection within this introduced ideology is confined to the specific places where the wealthiest people live and play, including their primary homes, second homes for their seasonal getaways, and the parks and wild places where they enjoy hikes and taking selfies. As colonizers dispossessed Anishinaabe of the Anishinaabe, our people from our homelands, colonizer ideologies concurrently displaced natural law. These ideologies are really more menacing and damaging than any introduced species. And they create the space politically and ontologically for invasive species and other ecological issues to blossom. So these are the things we need to keep in mind when we consider invasive species issues. And I'd like to think about invasive species together from this perspective through a quick example, the sea lamprey in the upper Great Lakes. So the sea lamprey were always part of the southeasternmost part of the Great Lakes. They're from the Atlantic Ocean, and they make their way up as far as historically as far as Niagara Falls. But their territory expanded greatly when industrialists and settler colonial governments conspired to create the St. Lawrence Seaway. So the Niagara Falls used to be a natural barrier. It kept the sea lamprey and other species from traveling further up into the Great Lakes. And Niagara, in that sense, was a part of natural law. It maintained territorial boundaries for certain beings, including the sea lamprey. But within the logic of settler colonial societies, it made good sense to break natural law, engineer a canal that allowed giant ships and other aquatic creatures to navigate around the Great Falls of Niagara. The same industrial thought leaders are responsible for destroying the falls at Powhatan. And so they channelized the St. Mary's River and the entire waterway connecting Gitchigame to the Atlantic Ocean. And giant ore and later container ships could then navigate all the way from Duluth to the Gulf of St. Lawrence and now across the globe from there. These same priorities, ideas, and ideals that created this super extraction highway were also used to establish a network of toxic industries along the shores of each of the Great Lakes. So it's critical to point out that this is not an historical period that we've moved beyond. In Powhatan, the U.S. Army Corps of Engineers has just in the past year started a rebuild of a newer, larger version of the Sioux locks. So the locks had reached the end of their engineered lifespan, and rather than seize the moment and restore our rapids, we doubled down, and we're increasing the capacity for more and much larger ships to pass through Powhatan in the future. So this audience is well aware that the US and Canada are shockingly lax on biocontrol of their borders and international waters. So these large ships that navigate around Niagara and up the St. Mary's River, they bring countless introduced species, including, but not limited to, sea lamprey. And the exchange of ballast water is loosely monitored at best. Every evening, an international fleet of giant ships anchors offshore shortly after clearing the Sioux locks and entering Gitchigame. So if you sit on a beach at night on the shore of Lake Superior, right before that outflow into St. Mary's River, you'll see ships anchored out there. You'll see them all lit up, and you'll hear these enormous pumps running throughout the night. And what they're doing is they're dumping water and aquatic creatures from the far reaches of the planet, and then they're in return sucking up fresh water from Lake Superior that I have to suspect is later filtered and bottled and sold. But the ships don't just bring lamprey, introduced mussels, or introduced plants. They also bring in a transient workforce made up primarily of younger men, both on the ships and in supporting roles on shore, like with the Sioux Locks Reconstruction Project. And these young men, by and large, lack local ties or responsibilities. They're not hiring locals for the most part, and a well-established pattern of frontier-style impacts follows. So this pattern includes abuse and murder of Indigenous women and girls. These industries and their workforces created demand for human trafficking. Abducted and indentured sex workers are brought onto these giant ships to please men on board. We recently had a man camp, so-called man camp, pop up in our community in Powhatan, just south of the community, to accommodate transient workers. And those places are notoriously harmful and dangerous to Indigenous women and girls. Rental housing in our community is now nearly impossible for locals to find. Rents have skyrocketed from this big rebuild of the Sioux locks, and they're anticipated to stay high for the next 8 years during the duration of construction. So back to lamprey, people have a lot of justified concerns about sea lamprey in the Great Lakes. Fishermen, resource managers, conservation groups, they all loathe sea lamprey because they have real and serious impacts on fish stocks, fisher livelihoods, and Great Lakes food webs. And lamprey impact native fish like lake trout, but it's noteworthy that a lot of the concern is over impacts lamprey have on introduced salmonids. Government authorities partner with NGOs in lamprey mitigation efforts, and this largely involves dumping pesticides into our rivers to kill sea lamprey. Related mortality impacts on local lamprey and eel species are rarely discussed, kind of brushed off as collateral damage. And then another impact of mitigation is that advocates for dam removal in the Great Lakes are faced with major political obstruction because dams block lamprey from entering streams where they would impact sport fishing and introduce trout. So we spend a lot of time and resources on lamprey mitigation. And it's not really an option to just leave the lamprey to their own devices. That'd be pretty terrible for commercial subsistence and recreational fishing communities, not to mention the fish who are parasitized by the lamprey. But my work in the past on invasive species, not that I assume anybody's aware of it, but I've gotten a lot of feedback that expresses a misunderstanding of the points that I've been trying to make. People misunderstand that what I'm saying is advocating for embracing all of these newcomers, or that we should stop invasive species work altogether. And I just want to be perfectly clear that what I've argued in my past scholarship is that all species deserve to be respected as valued parts of creation, and that it's not introduced species' fault that we moved them. It's not the lamprey's fault that business owners and engineers tried to outsmart creator by building the Wheeling Canal and the Soo Locks. Yet we treat introduced species as scapegoats all the time. Invasive species are not the problem. What they are is a predictable result of the invasive ideology of settler colonialism and American-style capitalism. Introduced species impacts are what you get when you break natural law, when you believe that economic growth justifies egregious environmental harms and human rights violations. Invasive species issues aren't going away. No matter how much poison we dump into our rivers, no matter how much money we spend on less toxic forms of mitigation, not until we figure out how to disrupt and displace colonial ideologies. Invasive species are just the poisonous blooms born on settler colonial trees. To address invasive species issues in meaningful ways, we have to do more than just remove those poisonous blooms. We need to begin uprooting the ideology that produces them. And if we remain complacent and ignore the toxicity of settler colonial ethics and economics, the economy will always come before the land and water. Job creation will always be played by industry as an unbeatable trump card, and invasive species will continue to flourish. I'm going to wrap it up there because I'm pretty sure I'm out of time, but I'm happy to discuss these ideas further with you. Miigwech.
I'm just coming back on here. Okay. Thank you so much for your talk. Great way to wrap up the session. I will make one very quick correction, which is that I am not actually in Sault Ste. Marie. I'm actually just outside of Toronto, and I work remotely for the Invasive Species Center, which is there. But it was definitely, as I've visited their head office, of course, a couple times, even as a remote worker, and it was good for me to get kind of that ecological history of the area. So on a personal level, thank you for that. I'm not seeing questions in the Q&A yet, but we do have like 6 minutes before we kind of wrap up for lunch. So if anyone does have questions, please pop them in the Q&A. I'll maybe see if I can kind of get us going here. So what you were talking about, it kind of reminds me of there was a lake in, I think, the Miramichi watershed. I want to say it was Nova Scotia. Maybe you know what I'm talking about. They were trying to eradicate smallmouth bass there. And 2 Indigenous women actually, they protested, like they blocked the lake. They went out in a canoe, basically, and you can't dump pesticides in the water when there's people out on the water. I guess I'm wondering, because you kind of see both things, right? Like you see different, like we know First Nations who are trying to do invasive species management like on their territory, and they see it as kind of, reclaiming their land. And I do to some extent see invasive species as, I think, as you were saying, like sort of a natural product of colonization. I guess I'm wondering, like, what do you kind of envision sort of like sovereign, like invasive species management in the future, in an ideal future where, you know, a post-capitalist future, let's say, kind of how do you envision that working? That's a big question. But
Well, I think it's actually a bigger question than the way you posed it, because it's not about how we address invasive species, in my view.
Yeah.
You know, it's in terms of talking about sovereign, basically indigenous groups having self-determination over how they access and how they care for and how they benefit from their territories, right? That's what you're saying. But you know, invasive species work to be a part of that in the future for sure. And so I think bigger picture, what it comes down to for me, and I know this is you know, is a big statement, but I 100% stand by this. I think that indigenous, first of all, this isn't as big of a statement. First of all, I think indigenous communities need to be entrusted with land tenure and water tenure responsibilities in all scenarios possible. I think that we need to be recognized as within settler indigenous relationships, we need to be recognized as the elder relative. You know, we've been here the longest. We know the most about this place going back eons, you know, whatever place we're talking about. In this case, you know, Bawating or the overall Great Lakes. And so we're not respected as like the elder knowledge keepers or the elders in those relationships, but we need to be. I mean, and especially in indigenous relationships with conservation community, with land management community, with settler governments, like we need to be recognized as the elder sibling or elder relative. And we need to be, in that regard, we need to be re-entrusted with land tenure and water tenure responsibilities in a very, you can't even say wholesale, but in all scenarios possible. And so to me, what is, you know, what that looks like is, you know, you're talking about, you know, kind of an idealized future. And I actually think that this is something that is on the horizon, and it's hard to say how far out. It could be 100 years. To me, that's tomorrow by our timescales and indigenous ways of thinking. 100 years is nothing. And so it may be 100 years out, hard to say. But what I see is down the line that especially public lands and conservation lands, they really need to be returned to indigenous stewards and indigenous stewardship, without excluding, you know, all the people in this community that are you know, people that are on this call represent a broader community that all need to stay involved and invested and employed. But we really need to be progressively turning over this sort of public land base of what are stolen lands. You know, with communities like my community, we own and control like very little by acreage, very little land, right? But we have neighbors, state, federal, NGO neighbors that have orders of magnitude more land that they're in charge of, and that we have to get permission slips to access. And there's something that's not right about that. And so so I think that that's a solution that's on the horizon, is that we're going to see more and more indigenous groups from Turtle Island being in charge of these what we recognize as like public spaces, and figuring out how to keep, and it's happening already, and figuring out how to keep them public, but put indigenous leaders in charge of decision making, and then keeping the rest of the conservation community involved and engaged.
okay, well, that sounds good to me. Well, to be honest with you, so I think we are just coming up on time here. I want to keep us on track for our break and then our next session. Nick, I want to thank you again so much for your presentation today. Definitely thought-provoking and very appreciated. Appreciate all of the speakers at our session this morning. Thank you so much once more to Susanna and Juliana as well. Just before I let us go for lunch, I did just want to note that we will be returning at 12:30. This is optional, of course, but for a networking session that will go till 1 o'clock. And so you'll be put into different breakout rooms that you can choose based on topics. And it'll be just kind of an open, somewhat guided, but really more of an open discussion-based activity. So I hope that'll be valuable to everyone. Still see some stuff in the Q&A and in the chat. I think we'll, if I'm not mistaken, for my colleagues, we'll keep the Zoom running, just not recording. So if anyone still wanted to continue to answer or respond to things there, please feel free to do so. But yeah, thank you again so much for joining us on the session this morning, and I look forward to seeing you again at 12:30.
Welcome back. I'm excited to introduce our next session to you. This session, so we at Risk spend a lot of time thinking about, and I'm sure you do too, about the effects of climate change on invasive species management, and impacts and things like that. And of course, climate change is affecting all aspects of life, not just invasive species management. And all around our region and the entire world, there are all sorts of innovative solutions being tested and deployed to mitigate and adapt to climate change. Many of these different activities or solutions involve either intentionally or unintentionally moving organisms into novel environments, and they may or may not really be factoring in potential invasive species risks. So in this session, we have a great group of speakers who are going to offer their insights into how the risk or even rewards of biological invasions are or are not being incorporated into the design and planning of climate change mitigation and adaptation efforts. And so we're going to start off with a talk from Andy Chang. Andy is an ecologist and the program lead at the Smithsonian Environmental Research Center. Each of our speakers are going to speak for about 10 minutes, and then we will have time for a panel discussion afterwards where you can ask questions in the Q&A, and we're looking forward to it. So Andy, I will stop my share, and you can take it away when you're ready.
Good morning or good afternoon, everybody, depending on where you are. Thanks, Dan, for your kind introduction here. I am going to share my screen. All right, I hope you all can see my presentation here.
Yeah.
Great. So I am more of an academic scientist as part of the Smithsonian, as Dan mentioned. And I'll briefly say that our main headquarters are in Maryland, and I run a satellite lab in San Francisco Bay, where we've had a home since 2000. Now, a lot of what we do is to conduct surveys for introduced species in coastal environments, freshwater, estuarine, and marine. So I'm an invasion biologist and a community ecologist by training. So that's the angle that I'm taking toward this. And what I was asked to talk about here was some of the risks and opportunities posed by offshore wind infrastructure, which is an excellent example of a rapidly growing renewable energy sector. So that's what I will focus on here. Now, it can seem a bit like no good deed goes unpunished with some of these climate adaptation and mitigation solutions. So there's a good thing that we're trying to do with them, and then there are some consequences. And I'm not here to pass judgment on them, but I want to try to provide some background information on the kinds of things that are worth thinking about here, and what we know and what we don't know so much about. So offshore wind energy obviously promises many potential benefits, and clean renewable energy is in great demand as we try to reduce our fossil fuel usage. And yet there are a number of challenges we face with the infrastructure that we put in place to enable this. So everything from the dangers that the turbines pose to birds, with bird strikes, to disruptions that might be caused by noise and electromagnetic fields. And I'm going to focus here specifically, of course, on what the infrastructure can mean for invasion by non-native marine species. So first, let's talk briefly about the process of invasion by non-native species. And I know we've heard a lot of bits and pieces of this through the course of the symposium here. So I want to review this briefly and then talk about how offshore wind infrastructure fits into that picture and might affect the landscape or seascape, if you will, of invasion. So very briefly, for a species to establish a new self-sustaining population in a location where it does not currently exist, enough propagule, so enough adults or juveniles, must get to the new location, survive, grow, prosper, and reproduce. So essentially, it's like passing through a series of filters, each one more stringent than the last, in order to establish that self-sustaining population. Now, in a nutshell, offshore wind infrastructure creates new hard substrate habitat in locations where it generally does not currently exist. And those platforms then get colonized by hard substrate dwelling sessile invertebrates and algae and a variety of mobile invertebrates, and they provide habitats for fish and larger animals in areas that otherwise are somewhat isolated. And these locations can serve as stepping stones in some cases for species to move from one location to another. So as we consider all the invasion stages here, we're not talking about a vector that's moving species around. It's more like providing new habitat and new kinds of habitat, and in locations where it didn't previously exist. So we're talking more about the middle part of this diagram, where we might be enhancing the possibility that more things can settle in a given area and then spread to other locations. So there are a number of different types of habitat that are brought into play as we bring in offshore wind infrastructure. First, we're introducing hard substrate, usually in places where it doesn't currently exist. Up in the bottom in those areas, it's more of a sandy or muddy type. And so now we've added hard substrate. And we have, as you can see in the diagram, different kinds of zonation. So there'll be different organisms living toward the top near the surface, and there will be toward the bottom. And it provides the habitat both for things that colonize the surface as well as the mobile invertebrates and the larger animals, the fish that live around and also near the bases of these structures. In doing this, we're also creating a new type of disturbance to the bottom of the sea floor there. So there's going to be some scour around the base of those offshore wind platforms, which will create a different habitat as well. So there are some effects on the soft sediment environment around and underneath the structures too. One of the things that is becoming more prominent as we develop deep water wind turbines is that they really create much more of a floating dock kind of habitat, which is a really novel habitat that doesn't exist in nature. And so these deep water wind turbines often have floating bases that will act like floating docks in isolated locations. And as a forensic marine ecologist, I know that floating docks are well known as a new habitat. They don't have an analog in nature because of their permanence, and they often contain these relatively unique communities, and they can be a real haven for introduced species. Part of that is because they're isolated just somewhat from predators that might otherwise eat all those species if they were on the bottom, as opposed to floating up in the water column. So we're changing the types of habitat that are out there and changing the habitat complexity that is out there. And we're losing, to some degree, some of the soft sediment habitat that was there previously. Now, as we put in more and more of these structures, you can imagine that the impacts will increase and they can act as even more of an island and as a location for new species to come in and settle, and then perhaps go from there to other locations. Now, very briefly here, I should say that this type of thing is not really new. There are many other structures that we have created and put out there in the oceanic environments. And broadly speaking, this sort of thing is known as ocean sprawl, where we're putting out more and more artificial structures and surfaces in the marine environment. And they do tend to support communities that are distinctly different in composition and functioning, including many introduced species. There is some, I don't want to call it greenwashing, but there's a very distinct take on how such platforms could be viewed and used by the industry. And so I don't want to say these are good or bad. I'll just note that oil rig operators, for instance, have taken advantage of the rigs to reefs program to reduce their cost of disposing of old rigs by decommissioning them and leaving them in place as new reefs, so to speak. And so there's a potential somewhat for similar sorts of things to occur with the wind platforms that are being put out there. Now, they are in some areas being promoted as conserving coral reefs, perhaps by providing habitat where corals can grow. And that's all well and good, but I'll point out that it can be extremely challenging to find out exactly what species are out there and what the composition is like and how many species and how often they're there and so on and so forth. And part of that is because getting access can be difficult for scientists like myself who want to study it and find out what's out there. So I would say that's one area where we need more information. The last point I want to make here quickly is that the location mattered. So the background source population of potential invaders that might colonize offshore wind platforms varies a lot from place to place. And as you can see in this figure depicting invasion from different parts of North America, there's a lot of variation from location to location in terms of how prevalent invaders are. So what you're building off the coast of England is going to be different from off the coast of New England or California. The other thing I want to mention here is that predicting what species will colonize and how many are invaders, that's one thing. We can do an okay job at that. But predicting which ones will have a big impact is quite another story. And so it's very difficult to determine which species will be the high impact one. And that's why we might try to focus on understanding what's out there and then trying to mitigate any transfers of species. I think I'm going to be a little bit short on time. So I will very quickly say here that it's worth thinking what kinds of mitigation measures we could potentially take here as we go forward into the future with more and more of these offshore wind infrastructure projects. It's worth thinking about and investigating questions like, can we develop structural arrangements and complexities for these structures that we're putting out there that will create the types of habitats that promote greater diversity and greater colonization by native local predators. And those are the factors that may help reduce the possibility of new invaders from establishing themselves. It's somewhat unproven and it's debatable in the literature, but it's worth considering. So with that, I'm going to wrap up here. Be here for any questions that we have in the panel session later. Thank you, Dave.
Thank you so much, Andy. That was really informative. And we're now going to jump from the ocean back into the terrestrial end with Melissa Cray, who is the director of the Forest Owner Carbon and Climate Education Program and an assistant professor in the Department of Ecosystem Services and Management at Penn State University. Melissa, you can go ahead and share your screen.
Great. I believe it's happening now. I think I've just frozen. And you may be hearing me now, but unfortunately everyone else is frozen. Try and stop share.
I hear you, but I think your screen sharing is still. Did we lose Melissa?
Yes.
Okay. Maybe we'll give Melissa a chance to log back in, and we'll just make a quick jump. But we'll keep it in the marine realm if Lindsay or I see her on, and maybe you can jump in. So we'll turn over to Dr. Lindsay Green Gavrielides, who is an assistant professor at Salve Regina University in Newport, Rhode Island.
Thank you. Hi, everyone. Give me 1 second here to share my screen. Okie dokie. And go into slideshow. All right, are we looking at my home screen? Is it notes view or not? Oh,
you're good.
It's good.
Okay, perfect. So I have been asked today to talk about some of the topics related to invasive species and climate change with seaweed aquaculture. So I'm coming at this from a perspective of somebody that's done a lot of work in seaweed aquaculture and also a lot of work in non-native species, but not really the two of them together. So I'm just going to show a few slides that I'm going to use as sort of a jumping off point to sort of start to consider some of the risks, some of the challenges, some of the ways that we might want to approach the aquaculture industry, particularly as it begins to grow and expand in the US. So it's kind of took a long time to sort of take off in a lot of ways, but has been growing pretty robustly domestically and certainly globally, though there have been declines in some places over the past, decade or two. So benefits of seaweed aquaculture, there are many. I could talk all day about how wonderful seaweeds are, but I kind of took a little bit of a snippet out of Carlos Duarte's paper in 2021, where he's really talking about how seaweed aquaculture can help us achieve UN climate goals. And I'm not going to focus so much on that, but I thought it was nice to sort of see these ecosystem services sort of laid out in a way. He's got them grouped into different categories. But if you're not like me and you don't spend a lot of your day thinking about seaweed and how to grow them, you might not realize how big it is on a global scale. So in terms of the production biomass, over 50% of global maritime production in the aquaculture realm is seaweeds. In 2018, so this is from the UN Food and Agricultural Organization, FAO, they produce globally 31.8 million tons of seaweeds, primarily for human food, but also for lots of other uses. And it is considered the fastest growing agricultural sector at somewhere around 7% a year. And so in terms of the ecosystem services that are directly sort of related to climate change, trying to think of, okay, they're photosynthetic, so can they represent carbon sinks? They can locally kind of increase pH during the day when they're photosynthesizing, though, the impacts of that are very site specific, and taking up excess nutrients. And so that's a lot of sort of the approach that I'm going to be discussing further. But of course, they're providing habitat. They might be increasing biodiversity while they're in the water column, food, products, etc. So lots of benefits, but from sort of an ecological perspective, primarily going to be focusing on nutrient dynamics. And so nutrient sequestration is sort of the big piece of this in terms of a climate strategy and in terms of growing seaweeds as a climate mitigation strategy. They have been probably underutilized in terms of removing excess nutrients from people in terms of nitrogen, phosphorus types of runoff from land-based systems, though in some places certainly used that way, or grown in combination with other aquaculture species like fish as a way of sort of reducing or minimizing, decreasing the environmental impact that farming things like fish can have. And then carbon sequestration is sort of the big, I don't want to say it's like a total question mark, but it's like an area of active research where there are unanswered questions and there's sort of debates. So it's not necessarily, there's not like everybody's in one camp right now in terms of whether this is going to be possible or not. But I think the more that we think about it, the more questions are being raised about whether seaweeds really represent a carbon sink. And so I have the asterisk there because I'm taking this picture from Max Troll and his colleagues in a review they published just last year, where there's a lot of information on here, but really the overall message, the argument that they're trying to make in this article is that seaweeds, the carbon that's fixed by seaweeds in photosynthesis remains part of the fast carbon cycle on the order of 0 to 10 years and does not become part of the long-term carbon sequestration cycle. That's a position that they've taken. I think there is you know, a lot of unknowns. So there's been, you know, suggestions about, you know, farming seaweeds and then like taking those and like sinking the seaweed into the deep ocean. And like, maybe that would be a long-term carbon sink. I think that's a place where we have like a giant question mark. Like we really have no idea what would happen to the carbon in the tissue if you did that. And so like, could it work? Could it not work? We don't know. So I think that's definitely an area of future research. But in terms of, you know, the production that occurs nowadays, the carbon is really short term. And that's because, you know, unlike trees, seaweeds don't have big structural components that can get buried and sort of lock up carbon for a long period of time. Like they're grown, they're harvested, they're turned into something. So like it takes boat fuel, which burns carbon to farm them. It takes, you know, there's a lot of resources that go into getting it out on the farm. And then there's a lot of resources that go into producing it. And then they're usually eaten by something. And then of course that carbon is going to be converted and some of it turned into waste products. So that's kind of one area where lots of people have been talking about this. Is this a climate solution? Can we fix carbon in this way? And like, I think largely we don't really know what the approach would be that would actually have this carbon end up in a long-term sink. But the approaches that we're using now seem like they're pretty squarely in the fast carbon cycle. Okay, and then so if we're kind of thinking about non-native species, I'm sure anybody that's familiar with aquaculture knows that there's a very long and extensive history of aquaculturing non-native species. I think it's over a third, it might even be more. I think it's a third of sort of farms are farming species in places where they're non-native on a global scale. And this is across all types of aquaculture, not just seaweeds. If we think about seaweeds themselves, Saccharina japonica, which is commonly known as kombu, it's kelp that's farmed in China and Korea at mass scales. As the name kind of alludes to, it's native to Japan and was introduced as an aquaculture crop. And so what is sort of the risk of doing that? I think this has gotten a lot more headlines in sort of fish aquaculture, but sort of escapism, risks of interbreeding with native populations or becoming established in a place and then going to be invasive where you're affecting native populations of other creatures. You know, I think that the question here is like, you can't really turn back the clock in a lot of ways. Like we're already doing this in a lot of places. And so the question from sort of a scientific and a management perspective is more of like, okay, should we scrutinize new operations more? And certainly I think, you know, within the confines of the US, definitely with seaweeds, we're starting to see that a little bit. And I'll touch on that on the next slide. But, you know, one of the questions that I thought was really interesting raised by Erickson and his colleagues in a sort of a policy document they wrote for actually Australia, but it is applicable here, is sort of asking this question: will there be negligible risk of introducing invasive species or pathogens that could undermine future livelihood? So having a more forward-facing view when sort of scrutinizing these operations, though you could argue like, we've been doing this for a really long time, both in the sea and on land. Like, is it fair to hold a different standard to this new industry that is going to be really important as we're trying to meet global demand for food security? So like these are sort of debates that are raging within the community, and I'm just bringing up the questions. I don't have the answers to all of this. So kind of zooming in more locally, one of the big topics that has been chatted about in sort of the seaweed circles as seaweed farms have begun to be permitted and grow and cultivate crops is sort of where do we get sources of baby plants? They're not technically plants, but we'll just use that for simplicity. And so this picture at the top, this shows you reproductive structures of plants. This is actually a picture of my kelp nursery at the University of Rhode Island when I was there. And so really all of seaweed aquaculture in the US relies on wild stock. So we go out, we collect reproductive kelp, through scuba diving generally, bring it back to the lab, release the spores, grow them on strings, plant them out on farms. There aren't, at least at this stage, there are not like cultures that you can buy, like you can buy a seed packet for land plants type of thing. And so the big question here is like, okay, well, if I'm growing in Rhode Island, where should I collect my source, like my genetic material from? And so the, I see it down. And this is my last slide, but the questions that are being asked are, okay, well, is there a risk of genetic pollution? So obviously the species is native here, but could we potentially be introducing new genotypes or different traits by farming something in a quote unquote new location? And I think the biggest question there is here, the biggest area for growth is basically needing to understand what the genetic structures of our native communities are. And that we're kind of moving in that direction, but we don't have a full understanding. And so it really just highlights the need to understand native communities and places where we're going to be farming coastal species. Yeah, I think that so I've raised kind of a bunch of different questions, but I think I will end it there, and I look forward to our panel discussion.
Thank you so much, Lindsay. Wow, perfect timing. So I think Melissa, we have Melissa back on.
Yes,
So,
I am.
all right, we'll give you so Melissa, as I'll reintroduce you, but Melissa is the director of the Forest Owner Carbon and Climate Education Program and an assistant professor in the Department of Ecosystem Science and Management at Pennsylvania State University.
Yes, I want to leave my screen off too, just in case that was a bandwidth issue. And do I have presentation mode? Or we look good to go?
You look good to go.
Awesome. I changed my title just to sort of mess with you guys. Sorry. No, I just thought this was a little bit better. I'm just going to give a quick overview from the perspective of a person who works in research and extension in the human dimensions of carbon markets and climate change in forests. And so this is my program. It's part of a large cooperative of extension and research professionals throughout the Eastern US. And this is one of my papers that I have published regarding who landowners are. They're family forest owners. The extension audience makes up about 35% of ownership in forests in the United States. Major group. How they approach decision-making about forest management is a balancing act. They would say it depends on the perspective they have towards the resource, towards their forest, and the ecosystem services, how much they're willing to accept as compensation, how much they're willing to pay. So concepts such as having skin in the game and doing right by the land is an important concept, but making sure management's financially feasible is also important. And there's a lot of needs-based decisions that are come about, not a lot of proactive decision making, more reactive, and a lot of them are looking to stack income streams. And so first question I want to help answer is, could the risk of climate change impacts motivate invasive species management? And, are people going, oh, what about my forest? And I'm going to say that right now, climate change is not a top 10 management concern among family forest owners. The Woodland Owners Survey shows the top 10 concerns here on the right, and you can see that invasive plants and disease are in that top 10. And so they're highly motivated. They really want to do something about invasive species. But then what are they actually doing about invasive species? So there's a wide gap between motivation and then actual behavior. So what goes on behind decision making about managing invasive species on private forest lands depends on the type of disturbance that may have led to the movement of invasives in. So in most cases in the Eastern US, it is associated with harvesting practices. What are the costs of managing those species? And then how do those species function on the landscape? Sometimes honeysuckle is a good idea. It really depends on the forest owner. I think it's important to point out only 10% have a forest management plan, and those plans are necessary to help them achieve their long-term goals and to prioritize the kinds of activities they're doing. If they don't have a plan, then they're doing this sort of reactive type of forest management, which is not always the best for invasive species and the long-term health of a forest, but this is the situation we're in. 15% have harvested trees, so they are harvesting and they are supporting a large timber economy, and this is primarily their only source of income that comes from forests. 25% do manage invasive species, so that is recognized as an important management activity, regardless if you have a management plan or not. I will point out that a third of our forests here in Pennsylvania are considered degraded, so that means they don't have enough economic value in order to justify investment. They could also maybe be places that's harboring invasive plants that could become seed sources. So there's a lot of challenges on private lands. So here's the big question. How can the carbon economy help support invasive species management on private lands? Well, we got to talk about which kind of practices we should be focused on. So creating new forests and protecting forest health have direct links to invasive species management. So I think that association is very clear, but there's this thing called improved forest management, which is the big buzzword of the day, that's kind of difficult to understand, especially in its context for maybe supporting invasive species management. Improved forest management is focused on working forest lands that have a risk of harvest and changing that risk by delaying harvest or extending rotations allows for additional carbon to be stored on the landscape. So that is the improved part, is basically delaying harvests in order to store more carbon on the landscape. So why should we talk about this? Well, 88% of carbon offsets projects in the United States are improved forest management. They're all based on delay harvest strategies, and this is much higher than where it is globally. Why is that the case? Well, we have strong private property rights that can guarantee when harvesting will or will not occur. We have established forestry practices that can quantify the amount of carbon sequestered over a delay period. We have a lot of middle-aged forests ready to harvest, so there is a risk of harvest that's present, and that is necessary to justify or to demonstrate that there would be additional carbon storage. And delay harvest projects are cheap to implement because you're paying someone to not do something for a little while, which is completely different than maybe reforestation projects and forest health projects where you've got a lot of upfront investment. So this is the dominant type of protocol that's being used on private lands. This here is a list of the different registries in the United States, and I've highlighted the protocols that they've approved specifically for smaller forest lands. These protocols focus entirely on quantifying and monitoring and reporting the greenhouse gases that were reduced or removed as associated with a delay in harvest. So there's nothing in these protocols that say, and invasive species management. So the question is, where does that come in exactly? It's important to think about offset projects based on their business plan and not just the protocols they use. So in Project A, the funding sources that come to support that project, part of it only comes from the carbon credit sales that are from delay harvest strategies. Other funding sources may come from NGOs, from state or federal grants, and those other funds can go to support a more holistic management approach, which includes invasive species management. This other project, Project B, is mostly supported through carbon credit sales. So it doesn't really emphasize invasive species management as being a priority associated with their particular project. I would say Project A looks more like the Family Forest Carbon Program, where Project B looks more like a conventional carbon program that you would see generally everywhere. So the business plan is really important as far as explaining how funding could go toward where it would come from to be put towards invasive species. Now, who would participate in carbon programs? Which landowners? And so this is another paper of mine that looked at a bunch of survey data, and we found that the amount they're willing to accept across different types of forest owners varied significantly, and how much they would accept as compensation for managing carbon through a delay harvest strategy. And so the green numbers represent values that are within the range of what our actual payment levels landowners could see right now with the current market, which is right around $10 per acre per year. So timber production oriented owners are looking more at their land as a form of investment, and delaying harvest comes with risks. So they're not really focused right now because the payment levels aren't high enough. But the conservation-oriented stewards who are willing to delay harvest, that's not a priority. They want to manage for things like invasive species. These are price levels that are of interest to them, and the conservation-oriented group is more motivated to reinvest in their forest, what the income they get from it. The passive forest owner is just that. They're willing to take income, but they may not necessarily reinvestment. So here's the answer. Invasive species management is not necessary for these delay harvest schemes, but they could still be part of the overall business plan. Forest owners who are stewardship oriented are more likely to use these payments to support invasive species management. You can see that there is a lot, as I said earlier in the presentation, a lot of folks are concerned about invasive species, but they just need to get that cash in order to make it happen. And in order to, put the carbon economy to work with invasive species on forest lands, prices need to increase. So we need to attract more types of forest owners with better payment levels and invest in better protocols and programs that have invasive species management. And so that's the end of my talk. I guess I could have left my slide up that showed my picture and my contact information, but of course, anyone's welcome to, email me. I'm sure the contact information is available. Yeah.
Thanks, Melissa. Yeah, we'll make sure all contact information throughout the seminar. And we have one more speaker before we get to jump into the panel. So I want to welcome Robert Lucas, who is the Restoration Coordinator at Raritan Headwaters Association. Robert, feel free to share your screen and take it away.
All right, is everyone able to hear and see my presentation?
Yep.
Thank you. All right, hello everyone. This has been a very informative and engaging symposium so far, and it's been a pleasure to be here. So thank you to everyone that helped bring this together. My name is Robert Lucas, and I'm the Restoration Coordinator for Raritan Headwaters Association. I've been working heavily on the restoration of riparian buffers in the upper Raritan River watershed here in New Jersey for the past couple of years. And today I wanted to share some of the challenges we've encountered in managing restoration projects in the face of invasive species and climate change. So just a quick background on RHA. We're essentially the local watershed nonprofit organization for the upper Raritan River, and our mission is clean water. We engage citizens and decision makers in the protection of our watershed and beyond through science, education, land preservation, and advocacy. The upper Raritan Basin consists of the north and south branches of the Raritan River, which covers 470 square miles, includes 38 municipalities, and consists of over 1,400 miles of streams that provide drinking water to more than 1.5 million people. It eventually drains out through the lower Raritan into the Raritan Bay, just outside of Manhattan there. A big part of the work we do is collect data on the health of our watershed and compile that into an annual report card that we can share with the community. The 2023 report card should be done shortly, but for now I'm able to share the 2022 report card, which shows an overall grade of D. The map is broken down into 52 sub-watersheds and shows that in most of these sub-watersheds, the trends are moving downwards in overall health. We generally have very good scores on parameters like temperature, oxygen, pH, and nitrates, but habitat quality, phosphates, and specific conductants all received an F. The poor habitat quality is very closely linked with the quality of riparian buffers, and climate change has played a big role in their degradation. So we sought to focus some of our restoration efforts there and began implementing projects in the fall of 2021. The goal of our project was to plant 10,000 native trees and shrubs in riparian buffers along the North Branch, Breton River, and any of its tributaries, and to ultimately restore 8 stream miles of buffer. We started by mapping buffer strength on public open space and sought to partner with public entities. Our focus was within the first 150 feet of the buffer, and in a lot of places we found 0 buffer with mowed grass all the way up to the water's edge. The picture to the right here is right along the North Branch and was the location of our first project. We got off to a quick start with the project and had multiple partners sign on, allowed us to plant 1,450 trees, restore 1 stream mile and 5.5 acres. And we were able to benefit from the help of more than 150 volunteers. But we also quickly realized that these mowed buffers pictured here were very easy to implement projects. And once we started to focus on sites riddled with invasive brambles and vines, we would find a lot fewer willing partners to tackle these projects. The challenge of an invasive species has made every project that much more complex and more intensive. At this site here, we had a half-acre site filled with porcelainberry and multiflora rose that took roughly 500 hours to clear in preparation for the tree planting. Once cleared, we were able to plant 115 trees and shrubs along the brook. The hours needed to prepare and maintain these sites has really challenged our volunteer base, as well as the staffing resources of our public partners. Oftentimes, the presence of vines becomes a non-starter for a project because there's not enough staffing to handle the project. And with all of these projects, there's only ever funding to purchase trees and tree protection materials, but never funding to hire contractors or extra staff to handle the site prep and post-planting maintenance to continue keeping vines off the newly planted trees. When we start to add up the number of hours that goes into challenging sites like this, we find, lost my place here. We find that per tree planted, there is a need for 8 to 10 hours of pre-planting and post-planting site maintenance. Just to focus on the financial burden that invasive vines and brambles play in these restoration efforts, for this specific site, if we take the 8 to 10 hours per tree and a $25 per hour pay rate, the staffing burden becomes $23,000 to $28,000 for a site needing 115 trees. That equates to $200 to $250 of labor per tree. This high cost also reiterates how much nonprofit organizations and public entities rely on volunteer networks to get climate resiliency and restoration projects done. And we don't anticipate this getting any easier. The need for riparian buffer restoration is exacerbated by the loss of ash and other tree species to invasive pests and pathogens. The emerald ash borer was first detected in New Jersey in the upper Raritan watershed, which also has some of the highest densities of ash in the state. The change in canopy cover to the right is a map that predates the arrival of emerald ash borer and is more closely linked to the rapid development of housing in the uppermost reaches of the headwaters. Deer density in our area is 10 times what is considered sustainable population numbers and requires us to protect every single tree or shrub planted, an additional financial burden for each tree. We often find that deer also outwit these standard deer protection materials, especially the bucks during buck rub season, and will often weaken and compromise the materials. In the end, this just means extra staffing time is needed during the fall and winter to regularly inspect sites. Climate change and the severity of extreme storms and higher temperatures only put more pressure on our riparian buffer habitats, with invasives leafing out before natives, spring coming earlier, southern species moving northward, higher disturbance frequencies from weather events, it definitely feels like we're on a hamster wheel at times, and I don't think any of us truly know how this will impact our streams just yet. The only thing that we might be able to say with some certainty is that our efforts to help mitigate the negative effects of climate change are only going to become more challenging and more expensive because of invasive species. When it comes to evaluating our efforts in mitigating the effects from climate change, our planning has faced challenges in the areas of funding, staffing capacity, regulation, data surveys, and invasive species management strategies. The degree of the funding burden behind invasive species and site prep has definitely surprised us. Staffing capacity, particularly amongst the public entities, is an ongoing shortfall. We would love to see regulation around banning the sale of certain invasive species to help ease the burden. Connected to both the funding and the regulation, the data available on how widespread some of these invasives are only muddy the picture. I looked up the data that was available on multiflora rows through the USDA National Invasive Species Information Center, and they only indicated that in all of New Jersey, there were 859 recorded sightings of multiflora rows, and we all know how wildly inaccurate that is. To summarize this financial burden that invasive species place on these projects, we are looking at costs on the high end of $275 in labor and materials to plant just one tree. And going forward, we will be advocating for better funding to support staffing capacity and managing invasive species, because our climate change mitigation efforts absolutely depend on it. And lastly, thank you to our funders for this project, the U.S. Fish and Wildlife Service, NOAA, and NJDP, and to our municipal partners so far. Thank you.
Thank you, Robert. Wow, these were all very interesting talks, and I'm excited to invite the panelists back up onto the Zoom screen. If you can turn your cameras on, and we'll get you spotlighted. I want to just acknowledge as we start this panel session that for this session, we asked many of you to sort of speak to areas of expertise that are only tangential to what you study or do on a day-to-day basis. So thank you for extending yourself. And in this realm of questions, we'll also be extending ourselves a little bit, because trying to find some common themes from seaweed aquaculture to riparian buffer restoration. But I guess I want to pick up on one of the questions that Ali asked, which is, I'm going to expand this a little bit, Ali, but just thinking about like many of these projects or many of these solutions that you've addressed have many groups of diverse stakeholders. So I just asking if you maybe could identify some of the stakeholders involved in the climate solution you study, and to what extent they agree or disagree about the risks of invasive species, to what extent they are even aware of the risks that are some of that you talked about today, and kind of where what is needed to kind of bring people along.
I guess I can start. So landowners are obviously a very important stakeholder group, because they have the ability to modify the landscape and the right to do something or not. And so I think when it comes to invasive species, there's in the case of extension education, we come across of a lot of well-intentioned people. It is not a values problem. It is a capacity problem, capacity in terms of knowledge or understanding of the issues, knowledge needed to execute activities. So whatever they need to do, create a management plan, work with consultants. And then there's the financial side too. So I think, it's the practical tools bit that is needed in the extension space too. And it's the same thing for basically a lot of the threats to private forest lands. So I'll just throw that out there, that's probably the case for landowners, usually.
Yeah, I can jump in. I think that, it's going to be a diverse stakeholder set for aquaculture communities, but of course, like on the front lines are going to be the farmers. And I think that they probably, there's farmers, there's business entities, management, regulations, state, federal. So you can kind of like branch out from there. But I think the farmers are probably more acutely aware of the impacts of non-native species, especially in my opinion, because oftentimes they're either actively or were in the past in the fishing community, or they are farming oysters, shellfish, other things, and they've been directly impacted by a lot of non-native fouling and things like that in the past. So I think on the ground, but there's obviously a disconnect when people that aren't working on the ground necessarily are also coming to the table. And I think, a lot of the management is happening at sort of the like, who's importing, who's exporting, or like, did this seed come from a state over, which of course species don't understand state lines, like they don't even wave at the welcome sign, right? So like there's a lot of questions there that are unresolved, but it's always hard when you have a lot of different interests involved.
I'll just speak very briefly to what I understand the wind infrastructure that I talked about. Similar things in some way to other structures like offshore oil rigs. So, and a lot of times the marine introduced species that occur in the communities that surround those structures are really just sort of a nuisance. And it depends a lot on the particular operator and the personnel on the ground, whether or not they care particularly about introduced species. So there's this somewhat tangential element of, I think, of a lot of what they do in their business. So that's one of those areas where there are, I think, some more challenges in how we approach that.
And I think I can piggyback on Melissa quite a lot with, landowners being the biggest stakeholder that we're working with here. And they're very much aware of the risks of invasive species, but it definitely always comes back to a staffing capacity and a funding issue to address the problems here. In New Jersey here, we're the most densely populated state in the country, and habitat fragmentation is quite an issue here. So the degree of which we are seeing invasive species and risks is in a lot of cases very high here. So yeah.
Thanks. Okay, so we also, we'll try to have a few more kind of big questions for everyone, but I don't want to also take away from more specific kind of question for individuals. So jumping to the Q&A, Lindsay, I assume this one's for you, but aren't there many native seaweed species that lend themselves to aquaculture, if markets exist or could be made to exist for them?
Yeah, absolutely. So I think, in the US, we're not, with the exception of maybe some land-based systems, we're not aquaculturing non-native species here. But I think, and I didn't mean to suggest that we were if I did, but I was sort of talking about aquaculture as a whole, that it's been historically pretty common for that to happen. But our biggest crop locally is Saccharina latissima, or the sugar kelp, and that is very widely distributed throughout the US.
Thanks. And so this is another question kind of, well, I'm going to start this one specific, but then we'll kind of open it up broadly. And so, there's a myriad of reasons to control invasive plants along river, but are there any, do we know to what extent invasive plants affect water quality? And I'll say, degrade, but also it could be positive. And I'll open up a more broad question. Are there any stakeholders or conceptual reasons to think that in some ways in the use of non-native species in these climate solutions may be beneficial? And I'll ask people, I was nervous to ask this question, but yesterday we had a really nice keynote from Laura Meyerson, who pointed out that you can have both negative and positive impacts and they don't negate each other. So I'll put it to you. So we'll start maybe with Robert, and then other folks can jump in.
Yeah, I think specifically in riparian habitats there. You know, there are definitely a handful of species that can provide certain functions to in their presence compared to natives. You know, the first one that comes to mind is, you know, Japanese knotweed can help stabilize and prevent sedimentation in water quality. And anything that is providing shade cover over the water to keep water temperatures down, really. There's another function there. So we take that with a grain of salt a little bit, but there are those functions that do get provided by certain invasive species.
I think when it comes to forest owners, the substitution for across different species as far as like the benefits is pretty loose. I mean, it's not like the invasive title has a negative connotation to it for sure, but only people who identify with sort of an ecological view of the forest or it's going to really resonate. Increasingly though, like the scientific ecological view towards nature is a very dominant view in the United States. So, so taking that lens is definitely common, but landowners are also much older. They're the boomer age, and so their response to the environmental lens is still somewhat complicated. And so, you know, their willingness to say, hey, I like this honeysuckle because it has all these benefits. Okay, so it's also invasive, but you know, like they make that trade-off really easily. So as soon as invasives start to actually impact their dollars, like as far as tree regeneration or any other attributes in the landscape that have monetary or non-monetary benefits that are significant to them, then that's when they go, okay, now that's a problem. So it's I would say, yeah, it's definitely a function of age, generation perspective, and trade-offs, and that's going to be based on their local conditions.
Yeah, I think I would say that we know of examples in aquaculture where invasives have had really big benefits to society in terms of food production. Like a lot of people rely on, for example, like the Nile tilapia, which is an incredibly invasive species in many areas where it was farmed. And so, you know, it's these types of conversations, when you come at it from an ecological lens, which is my, you know, personal bias, you might be you're coming at it with sort of a like, oh no, it's having these negative effects. But when you zoom out and you start to appreciate other people's point of view, like people need food to feed their families. People need jobs to pay their bills. People need, you know, to make money, as sort of like going off of what Melissa said, when it starts to affect people's bottom dollar. And so it can get very complicated, but yes, of course, there's going to be benefits to some of it. It's just sort of like what I think as a society, we have to have the conversation of what are we willing to trade off, like go into it with open eyes rather than ignoring what are the possible outcomes of these scenarios.
If I could very briefly add to that, I completely agree with what you've said there. Now we have to view that as a society and see, all right, what are the benefits and the trade-offs there. In marine conservation, there's lots of examples where we know there are non-native species that perform particular ecosystem functions better than their corresponding native species. Perhaps like one reason why they're so successful, but also in a restoration context, they may be useful there where a native species doesn't do so well, but we can create perhaps a better functioning local marsh by using a cordgrass that is introduced from somewhere else, or provide better habitat for a threatened and endangered species. So there are numerous examples of that in my local area here in San Francisco Bay. So you have to come at it and look at the whole picture and make that decision as a society.
Great. Well, thank you all so much. There are we're out of time. There are a few kind of more individual questions in the Q&A box. So if panelists, do you have time to stick around and type a few answers that are specifically addressed to you? That would be wonderful. And thank you again so much for participating. And up next, we're going to hear a few lightning talks.
Thank you very much.
All right. All right, everybody. I'm excited to start the lightning talk. And first off, hopefully we can see this. So here are our speakers. And so we're excited to have 4 speakers who are going to be giving us a short flavor of some of the work that they're doing. These talks are going to be about 5 to 6 minutes long. And just for the interest of time, we're going to have all the speakers give their talks and then have the question and answer portion afterwards. So there will be a lot of time for that. And so without further ado, I would like to welcome our first speaker, and I can stop sharing my screen. Yeah, we have Dr. Kristen Ross, who's an assistant professor of wildlife and forest of conservation from Vermont State University. And her talk is entitled, "Is Black-Legged Tick Nymph Density Associated with Invasive Plant Species in Rural and Private Woodlands?" And so this is something I'm interested in because I'm out there looking, searching for invasive species, and I often encounter ticks. So with that, thank you.
Sure. Good afternoon, everybody. Thanks for your attention. And this is part of a larger study. This is actually a tiny part of a larger study that's funded by the New England Center of Excellence for Vector-Borne Diseases. So I'm going to be briefly presenting some information. We just started collecting this past summer with some student researchers who I'll mention here, Callie Wooster, Luke Walters, and then my other co-PI on this, Bill Landisman. So let's jump in with a little bit of the study context here. We're focused on privately owned woodlands here in Western Vermont, and we have the common things that we've seen in other places in the Mid-Atlantic New England states that are issues, Japanese barberry, and we also have European barberry, the bush honeysuckles, buckthorn, and then obviously another problematic species here are black-legged, or some people call deer ticks. And we're going to focus on the nymphs here because we think that those are more dangerous to people, not because of their pathogen load, but more because they're harder to see when they're on you if they become embedded, so people miss them. So when nymphs are most active here in, at least in northern New England, in the spring months, May and June, and probably even earlier this year, that people tend to miss them on themselves or on their pets.
Sorry to interrupt.
Yeah.
Are you sharing a presentation right now? Because we only see you. We don't see a screen.
Oh, you don't? Yes. Okay. Sorry about that. It must not have gone. Let's try this again. Thank you for interrupting. Here we go.
There
Okay. Yeah. Sorry about that. I'll just go back to my titles here so you can see the co-authors, and then I just showed some pictures of species here, so probably ones we're familiar with. So the context for this comes out of other work. There's many other studies that have associated invasive plants, especially shrubs in forested areas, with ticks. This is out of Scott Williams' group somewhat recently for a long-term study that showed where in Massachusetts and southern New England states where there was no barberry, or barberry had been managed over the long term, there was a reduction in not just tick densities, but also the pathogen that the ticks carry. And then we're here in Western Vermont, and like other northern New England states, we've become the hot spot for many tick-borne diseases, especially Lyme disease. That we have long-term tick densities studies on since about 2014, but we sampled 7 of those for vegetation this past summer. And you know, as the climate is warming, the prediction is that ticks will become more abundant and move up north. This is an issue up in Quebec as well. And so just as a sort of accidental study here, one of our private landowners took it upon himself to remove Japanese barberry from his site. And this is just showing long-term the nymphs density at his particular site. He was kind of had high tick densities. And then he removed his barberry in 2019. And after that, so far, we have not seen the high tick densities there. So his site went from a high tick density site to a low tick density site. So we wanted to see, is this relationship there in northern New England? And a lot of our sites have lower density, fortunately, of invasive shrubs. So we're using this drag cloth method along about 400 meters squared per site, and then we're recording percent cover and height classes of our target species invasive plants along the transect. And so the next couple slides are just quickly showing you not very much, not a great relationship, not any relationship at all. In fact, black-legged tick nymphs were seen, at low densities and at high densities, mostly when this is looking at common buckthorn sites, not a lot of shrub cover there. And same with bush honeysuckle, don't really see a great relationship here. And this is just these two graphs were from just 2023 data.
I think we have a little bit of a pause.
Species, let's take all.
Oh no, you paused for a little bit. So I was just making sure.
Yeah, okay. Yeah, the internet connection may be questionable. And then, if
Maybe
you look
turn
at all
your camera
off. Yeah, I'll try that. See if that helps a little bit. And then the long-term data set, again, when you take all invasive plant cover together, also doesn't show much. At least not for this first year of data. So our takeaways from year one is that right now, at least at the densities we're looking at for invasive plant cover, there isn't a real relationship between invasive plant cover and black-legged tick nymphs. So now we're going to try to find some sites with higher densities so we can do a different scale study of low density versus high density, and then incorporate other factors. Obviously, ticks are very interested and active when the humidity is just right, can't be too wet, can't be too dry. Obviously, the host community also matters for those large mammals and small mammals. And then landowner management, we're going to start hopefully working with some other landowners who will agree to remove some invasive species and see if we can get more than just one area there, one site to look at some data. So thanks, and that's it.
Perfect timing. Thank you for that presentation. The next one we have is Eve Allen from the Northeast Bioregion Program, and she's a director there of the Ecological Health Network. And she'll be talking about developing an ecological restoration activities database for the northeastern United States. So with that, take it away.
Thank you so much. Good afternoon, everybody. My name is Eve Allen. Next slide, please. So I work at the Ecological Health Network. We're based in Cambridge, Massachusetts, and our mission is to accelerate the understanding and awareness among scientists, policymakers, practitioners, and the public about the long-term benefits of ecological restoration for human health and the ecosystems that we depend upon. You can scan that QR code to learn more about us. Next slide, please. So for the past few years, we've been working on catalyzing the Northeast Seed Network with many collaborators here in this logo soup slide. And I think you might have heard a little bit more before from my colleague, Michael Piantadosi, about the network. But what we're trying to do is simultaneously develop all of the key stages of native seed and plant material supply chain so that we can increase the accessibility of source-identified, genetically diverse seed and plant material for a wide range of restorative activities that are taking place here in the Northeast. Next slide, please. And one thing that we're finding right now is while we're gearing up to increase production, And we know that there's a huge demand for native seed and plant material. We're unsure how that demand actually breaks down into intelligible markets that we can make sure that our producers can access easily. And last year in 2023, the National Academy of Sciences put out a report, and one of their key findings, and this report was about our nation's native seed and plant material supply. One of their key findings was that uncertain market demand is one of the major barriers that prevents a thriving seed industry, and that those poor or inconsistent demand signals are especially disadvantageous to small growers. And in my work, I talk to a lot of people that are either on the end use side or the production side, and it's a bit of a chicken and an egg situation where end users might not want to start purchasing from local suppliers because they're not sure if there's going to be a reliable seed source, and the growers might not want to take the risk to start growing new things because they're not sure if they're going to be able to sell them. So we're trying to figure out how we can develop and strengthen demand signals and learn more about what the demand is in our region for native seed and plant materials. Next slide, please. And so one of the things that we're doing is developing a new partnership or a new coalition that will be distinct from the Northeast Seed Network, but will really focus not on the production, but more on the end use. And we want to influence and shift the policy, regulatory, logistical, informational, cultural barriers related to enhancing more use of native seed and plant material supplies that are produced regionally for a very wide range of restorative activities. Next slide, please. And so in this coalition, what we want to do is undertake scientific research, do education and outreach, and build capacity through a network of networks approach. And this is, again, to improve the demand signals so that we can make sure that the highest quality, most appropriate climate-ready seed and plant material is available to end users in our region. Next slide, please. So now getting into the database project, I've tried to set the stage as to why it's important that we understand more about restoration in our region. Enhancing the science and the practice of ecological restoration does rely on synthesizing data and exchanging knowledge. And for designing and implementing long-term, effective projects that allow us to mitigate climate change requires monitoring and a detailed understanding of the outcomes of previous and ongoing restoration activities. It's not just important to know what projects are successful, but also to understand project failures. Next slide, please. And while there are other restoration databases that exist that are excellent, in the northeastern United States, in our region, we are constrained by databases that either have very limited resolution or low spatial or temporal coverage. We have global databases, but they lack the sufficient local resolution that we need. For example, the Society for Ecological Restoration, they have a database, but it only includes 26 restoration projects across both the Northeast and Mid-Atlantic states, which represents a fraction of the projects that have been completed or are underway in our region. Local databases are either highly specialized to an agency, area, economic sector, or ecosystem type, and then consequently, they lack the capacity for data synthesis and integration at a strategic level that could heighten the effectiveness of restoration activities across the region. So currently, no comprehensive database exists that consolidates and standardizes information for the array of variables about restoration initiatives that are undertaken or have been previously completed. Next slide, please. And so we propose to actually create a regional specific restoration database. And we want to include not only project sites, but a repository of reference sites and technical resources that can help support climate-informed native seed and plant supply chain use for future ecological restoration projects. Next slide, please.
I think
And
we're
so-
almost out of time, so if you could wrap it up.
Sure.
Thank you.
Sorry about that. And so what we anticipate as an outcome is that this will enable land managers and other practitioners to learn from one another, adopt proven strategies, and coordinate efforts at a larger scale. And this will help us understand or increase the resolution on the trends of native seed and plant material demand to support our production planning. And so that's it. Thanks so much for your attention. Next slide, please. Please get in contact with me if you want to learn more.
Thank you for that presentation. So next we have Matthew Furtakos, and he's a graduate student at the University of Massachusetts Amherst. And his talk is entitled Creating a Climate Smart Native Plants Database. So yeah, we see your slide. Perfect. I think you're muted, so if you could unmute.
Yes, there we go. Cool. Hi, everyone. I'm Matt Furtakos. I'm a member of the Northeast RISC, and I'm excited to give a very brief preview of a management challenge that will be coming out later this year, which is we've titled Climate Smart Gardening. So a garden filled with native plants provides countless benefits compared to a non-native garden. There's less risk of invasion because native plants are less likely to escape gardens and become established in the landscape and then subsequently have negative consequences. Native plants support a greater diversity of native wildlife in our area. They're built and adapted to survive in the climate of the Northeast, and they subsequently require less care like watering, and of course, they're also beautiful. But climate change is shifting where plants can grow. So this map shows how hardiness zones have shifted in the Northeast since 2012. This is from the USDA. And in just over 10 years, most of the Northeast has had at least a shift of at least half a hardiness zone, which is shown here in orange, corresponding to an increase of 5 degrees Fahrenheit in the average annual minimum winter temperature. But of course, over the coming decades, climate change is predicted to further shift hardiness zones in the Northeast. So this figure on the left shows hardiness zones today, and on the bottom left is where hardiness zones are predicted to go in the worst case scenario by 2070 to 2090. And this corresponds in the Northeast to about a change of 2 hardiness zones. And so the consequences of this are that plants that grow in certain areas now may not thrive in that area in the future. And an example is fire cherry or Prunus pennsylvanica. And this is something that currently grows in Massachusetts and has a hardiness zone requirement of 2 to 6 optimally. And it's something that we predict will not thrive in Massachusetts in the future because the lowest zone projected for our area is 7 under this worst projection. So gardeners have to be anticipating these changes for the long-term survival of their gardens and to help increase future adaptation. So our forthcoming management challenge hopes to address this by creating curated lists of climate-smart native species for Northeast gardeners. And we went about this by surveying 357 nurseries across 15 states in the Mid-Atlantic and Northeastern United States for native species that they currently have for sale. We then took a variety of resources and appended horticultural information like hardiness zone, habit, moisture, light, pH, maintenance level, benefits to wildlife, and aesthetic information. And we investigated if the hardiness zone requirements for each species will persist in each state currently and under future worst case climate change scenarios. We also filtered out rare and endangered species to avoid the encouragement of collection from natural populations that are currently threatened. And then we are working to have our list reviewed by regional botanical experts. So an example of this is we recently ran a workshop at the New York Invasive Species Expo where managers were provided one of our draft lists of species and the garden attributes along with it, and they provided us feedback and we've integrated their changes. And so ultimately we'll end up with one list for each state, and these will also be further reviewed by botanical experts. So the resulting lists contain across all the states of interest about 750 native species, which are predicted to persist in an area under future climate conditions. So now I'm just going to provide a quick preview of, or an excerpt of what a state list could look like. So in addition to providing the scientific name, we include a common name and the horticultural information that can help a home gardener find what they want to plant and will work in their area. So for example, if for some reason you have an abundance of toads or frogs who are in need of a home in your yard and want a low maintenance plant that will persist under future climate conditions in New York, then the northern maidenhair fern might be for you. We are also in the process of developing a web app for users to more easily create a curated list of species for their area. So users will be able to select the attributes they're looking for, like soil moisture and season of active growth, and receive a list that best fits those criteria based on their specified location. And I just want to shout out another RISC member, Thomas, who's going to be speaking after me, who really worked to develop this with an undergraduate named Kabira. So we're also looking for more people to get involved. We're looking for species reviewers for the list. So if you're a particular botanical expert in your area and you want to help contribute to these lists, you can scan this on the right here and sign up to help us. We're also just looking for beta testers for the online app once it's further developed to help us find bugs. And we're also collecting any comments you may have. There will also be a link in the chat that contains this as well. And finally, I just want to give another thanks to all of my other RISC co-authors, Jenica, Eve, Thomas, Matt, Caroline, Suvi, and Trista, who helped kind of bring all this together, and we're still actively working on it. So something to look forward to. Thank you.
Thank you for the talk. And then to round out the session, we have Thomas Neufer, who is also a graduate student from the University of Massachusetts Amherst. And his talk will focus on risk assessment, restoration, and range shifting plant traits.
Yeah, thank you so much. So Matt's talk was, just sort of looking at those plants which are going to stay in your region in response to climate change. And I'm going to kind of focus on the ones that are on their way out. Just get my slideshow started here.
Right, we see it appearing. There we go. Perfect.
Okay, wonderful. Right, so today, again, I'm Thomas Neufer. I'm a PhD student at UMass Amherst. And today I'm going to compare some of the traits that are used in risk assessment for range shifting plants in the context of restoration and assisted migration. So just to set the stage, we know that restoration projects have this huge climate adaptation potential. They pose an opportunity to support facilitated range shifts for those native plant species which aren't able to track their climate niche independently due to the rapid rate of climate change. We know that the Northeast is posed to be a hotspot for range shifting plants and has also been host to climate refugia in the past in periods of historic or prehistoric warming. For the context of this talk today, I'm going to be talking about species whose climate niche is moving outside of their historic or current distribution, but still within a landscape with some shared evolutionary history due to proximity and, again, those prehistoric range shifts. So, for example, plants which are native to the United States and to the East Coast, but maybe historically limited to farther south than here in Massachusetts, where I'm located. And some of you may already be wondering how to think about, control, or utilize range shifting species, or even how you might facilitate range shifts as a climate adaptation method. So when we consider facilitating these range shifts via assisted migration or range expansion in a restoration context, the ideal scenario is that we see positive conservation outcomes for the species and, neutral or positive restoration outcomes for the landscape as well. But there's also these two unwanted scenarios at the bottom here. The first being that in the new range, the species becomes overabundant, contributes to competitive exclusion, unwanted impacts, that it acts invasive. The second is that the species is not able to survive outside of its current range in that restoration context. And so it fails to establish, and we've spent time and money and plant genetic material without meeting those conservation goals. So we're looking for a species that's going to be successful, but not too successful. How do we predict where the line is going to be between a resilient plant and a risky plant? Well, there's a body of knowledge from invasion ecology about how traits can inform, plant traits can inform species abundance and performance outside of their range, with the idea that these traits can confer inherent risk. And existing guidelines around assisted migration and range shifts and literature around these topics draw heavily from that invasion ecology literature and make use of some of these risk traits. For instance, the IUCN risk assessment guidelines for translocation name traits analysis as one tool of risk assessment. But for the restoration managers in the audience, this sort of packet of seeds for a species that's highly specialized, has low offspring survival, is not tolerant of disturbance, etc., might not seem like a very appealing purchase for a climate resilient restoration landscape. But those traits come directly from the invasion ecology literature. And from, in fact, the National Park Service cited this in their report on assisted migration best practices as being linked to a decreased likelihood of invasion. So they decrease invasion risk, but they may not be sort of the most practical in a restoration context. Sorry, my office light is motion activated, and it just goes off at the worst times. So when we look at the literature more broadly, what we see, these are some traits that are pulled from case studies, weed risk assessments, meta-analyses. And the traits on the left in this orange circle here are those that are linked to an increased risk of invasiveness or weediness. The traits on the right here are those that are cited as being valuable or necessary for success in restoration or in nursery production, which is obviously going to be very context dependent. So this isn't a comprehensive review, but we do see already significant overlap in some of these traits. Those that are related to resource acquisition strategies, biogeographic traits like a broad abiotic niche that kind of get at generalist tendencies, and some reproductive and dispersal traits linked to like persistent seed bank, wide dispersal, and those are associated with both a plant's fitness as well as its ability to spread. So why do we see so much overlap between what counts as sort of a risky plant and what's a successful or resilient plant? Well, trait studies in invasion ecology can range across the whole invasion continuum. So some of these traits are maybe more descriptive or predictive of generally establishment in the new environment. Some of them may even sort of be linked earlier on the invasion continuum. For example, like to selection or introduction, with ornamental plant trade being such a common pathway of invasion for plants, it's not surprising that many invasive plants have traits that are suitable for nursery production, so that doesn't necessitate a causal relationship. And this may not be as much of a problem, this sort of blurriness across the invasion continuum, for risk assessment for long distance, non-native plant introductions, where we're using the precautionary principle with good reason. After all, a species which is not likely to survive is not likely to be invasive. But for the goal of assisted migration, we need to take into account that outcome of a successful establishment and climate resilience for these plant communities. So the stakes are a little bit different. And because of those different stakes, I think one takeaway from this kind of comparison of traits is that we're likely to need to be more risk tolerant when thinking about assisted migration and restoration than we are when we're talking about non-native plant introduction. Risk assessment research also should be mindful of its focus, looking at traits which are specifically linked to the late stages of the invasion continuum. And for our own work, identifying and comparing and contrasting these traits is a first step to collecting data and attempting to quantify risk level at a species level in a practical way. And finally, that this is an area that invasion ecology and restoration ecology should be speaking to each other probably a little bit more than they sometimes do. And we should be aware of what's necessary for a plant to actually be practically feasible in restoration and seed production, knowledge which comes from practitioner and manager communities and from events like this one. So if we can focus on these traits in the orange here, or those like them, which are related to invasive risk, but not necessary for restoration utility, we may have better success identifying low-risk species which are able to be successful and better outcomes bridging research implementation gaps for these strategies. Thank you so much, and I'm happy to take any questions. You can contact me via email.
All right, thank you. We have time for maybe like a couple questions, so if we could have the speakers available again. We do have one question. This one I think is geared towards Matthew, and it reads, I'm curious about the conversations you've had about not including threatened and endangered plants on your list. And we've had some conversations, but struggle with the idea that excluding them is good. Could including them possibly get them established more broadly and then off the T&E list? Is this mostly a regulatory limitation?
Yeah, sure. This is definitely something that we grappled with within our own group, going back and forth about should these like rare plants be included on the list or not? And I think it came down to just being better safe than sorry. And from feedback from managers that there is poaching that occurs when you encourage people to get some of these plant species that maybe are less common, and they're especially less commonly sold in the nursery trade. So we wanted to be more careful about encouraging these things. And also, it just from a feasibility standpoint, these rare plants are rare for a reason, and a lot of times that means they're harder to propagate. So yeah, it could just lead to more poaching that we don't want. So we're just being safer than sorry.
Right, excellent. I did have a general question. I know because native plants are something that we're trying to promote. Is there anything we could do to increase accessibility to some of these resources? I know it was mentioned in some of your talks. Accessibility towards maybe like the home, like an individual or underserved communities who might want to buy and get these native plants, and it might be pricey in some areas. So any strategies that could help land managers or partners? That could
Well,
be anyone. Yeah.
I could say that the Northeast Seed Network, we're working on that. Like we have to amplify seed and plant material, and if we're, growing it regionally and making sure that it has, it's source identified, it's genetically diverse, or it has local ecotypes, the more that we can specify that plant material and increase the demand signal, increase, just the demand in general, then there will be more of a surplus and hopefully the prices will come down. But it's very complicated. There's a lot going on there. But I do know of some groups like the Wild Seed Project in Maine, and they're working to make seed accessible for underserved communities. You might want to check out their programming, and I can put some links here in the chat for more information.
Perfect. And we did have something in the chat. It's been noted by many during the symposium that the dominant presence of Japanese barberry as an understory shrub species can be a symptom of overabundance herbivory by deer. And example, the deer ate the native plant and left the barberry. And deer, of course, harbor deer and other ticks. So arguably the need to also control the deer to control the ticks was something that was mentioned. So have any thoughts on that?
Yeah, I mean, that's part of, and I appreciated Melissa's talk earlier about getting, incentives for private landowners in New England. We have more private land than public land. And so if you can intersect some of those concerns like carbon issues or disease, public health issues with, combating or controlling, managing some invasive plants in forested landscapes or other kinds of landscapes that either farmers or landowners are concerned with. That's kind of our goal. Is we have a lot more concern about getting Lyme disease than we do about invasive plants, or at least around here. And but everyone is asking, what can we do to get rid of ticks? Everyone. So if we can have a couple, and a lot of people don't want to use chemical means for a variety of reasons. So we're trying to come up with some things that we can offer to people, but also based on evidence. So, which is, everybody's way of managing lands and their incentives and their motivations are different, just like everyone is different. So that's the complicated fact, is working with the plants and the ticks is less complicated than working with the people sometimes.
All right, thank you. And then just one final question before we wrap it up. I know, Thomas, you had this, amazing list, like the orange and the green list. And so there's like all these different traits. If you could just like highlight maybe a couple like key traits that maybe we could just really focus on, just, because presenting that whole list it's very information dense. So I'll just highlight maybe a couple things that we might push.
Definitely. So, I mean, I think the big, takeaway with all of those traits on the list is that there is this big overlap between these sort of risk and resilience traits. But, I would say like some of the things that come out as being linked to invasiveness, invasive classification, but not really showing up as much in the restoration literature. I mean, there's some obvious stuff like toxicity or carrying pathogens, that are kind of related to unwanted impacts. As well, I think that there's some sort of like evolutionary, like having invasive congeners being reported as invasive elsewhere, that those are going to be like good, hallmarks that aren't necessary for restoration. I think there's a lot of like work being done genetically as well around genome size and levels of ploidy. So it's something that, that I'm sort of still digging into, but those would be some of the ones that come up, initially as being, kind of firmly not necessary, for restoration, but definitely unwanted in the sort of Invasiveness Risk Institute.
All right, thank you. And with that, I think I'm going to turn it up to Eva, and we're going to kind of conclude this seminar portion. So Eva.
Where am I? Okay. So thank you all so much for joining us. We're going to go through a really quick recap of all the things we've seen over the past 2 days. So first of all, we had our keynote with Laura Meyerson, who gave us a great overview of the IPBES report findings on invasive species and global change. We saw our panelists from our early stage invasions talk about cool tools and case studies in modeling, monitoring, and early stage management. And then we learned about the role of climate change in decision-making, about what to do about late-stage invasions. We saw some really cool juxtapositions between marine and terrestrial cases. Thank you so much for contributing to that discussion. We honored Vice Chief Richard Sillyboy of the Mi'kmaq Nation with our Community Action Award. And then today we started with some much needed discussion on the power of word choice and being intentional with the language and underlying assumptions of invasive species management. I don't know about your breakout rooms, and I'm sorry for the tech issues there, but I was really excited to see some connections between what we were talking about with policy, continuing on with the panel on invasive species in climate mitigation and adaptation strategies. Thanks, Dan, for running that discussion. And then we saw some great lightning talks just now with a really great diversity of issues too. So thank you so much for being here, for listening, for contributing, whether that was via Q&A, via the chat, via just reacting to people, just hanging around and being somebody to be listening to this, to be interested, and to maybe carry on with some of this information into whatever you do next, however you interact with invasive species and climate change in your own lives. We do have a QR code for a survey as well as the links in the chat. So please do let us know what you thought and how we can improve for next time we have this symposium. And stay in touch. We're always happy to connect with you all, and thank you so much for making this year a fun one to be a part of.